All right, so let us have a continuation on our isometries. This is the last isometry on our transformations that we are going to consider, which is our rotation. So I want you to put this in mind just to summarize the first two that we had. Remember, we talked about the translation and also the reflection. So I just want you to remember about what we had. The translation and its properties, all right? Where we talked about the most important part being the translation, the reflection, and the rotation being the isometries. Remember what I said before. So I'm just going to bring you back. You understand me very much. So I say that what brings these three, why are we talking about these? Always, why am I talking about these three? They have a special property, which is the same for these three. They have the same property. And what property, which property is that? The congruency property, the isometry. They are isometries, meaning to say that they are congruent. The object and the image are congruent. So we are saying the object, thus the object. Now you understand me when I'm talking about this object now. Thus the object and the image are congruent. All right, so now you understand me if I'm referring to this object image from translation and reflection concept. All right, so they share this property, like that's the major property they do share. So once you see the object and the image being the same, you see there's nothing has changed. It's only maybe the position to say the triangle was at this point. Now the triangle, but the triangle, the object, they are exactly the same. Only that the position has changed. You are going to think of these three. That is, you summarize from, okay, I'm supposed to have a translation, I'm supposed to have a reflection, I'm supposed to have what? A rotation. These are the three transformations that you're supposed to expect. But now, of these three transformations, you now need to specify, okay, how are you going to see, okay, this is a translation. Remember what I said. For a translation, we are going to have parallel lines of equal length. We are going to produce parallel lines of equal length when the corresponding points are being joined. When you join A to A1, B to B1, C to C1, you are going to have what? Parallel lines of equal length. But they are from what? Isometries. That's the first thing. All right. For a reflection, it is the same. We are going to have also parallel lines. But these ones, they are of an equal length. All right. So remember, I said these are of an equal length. Once you see this, you can now conclude this is a reflection now. You now describe. Remember how to describe. I'm not going to talk about that. But for a rotation, this one, it's not about parallel lines. When you join these corresponding points, A to A1, B to B1, it's not going to be parallel at all. So meaning to say this one, it's an advantage that it totally gives us what is different from the other transformations that we are given. This time, if I'm to join maybe A to A1 like this, then B to B1 like this, you are going to see that there is a part that is going to meet. They are going to intersect. There is going to be a point of intersection. All right, do not conclude. Do not conclude, please. It's just a point of intersection, that one. The moment that you see this happening, whether it happened between 2 points, A to A1, B to B1, maybe it happened between B1 to B and B1, C to C1. But there's a part that is, you see, guys, lines which are parallel, they are not difficult to see. You can by sight, some of these things by sight, by just looking into the lines, you can see these lines are parallel. They will never meet. They are lines that you see, a line drawn like this. Look at this line and this. Even because you can even check to say, if I was to correspond, if I was to continue this line and also continue with this line, what was going to happen? They are going to cross at a certain point. So sometimes it's not like when you join, they are going to automatically cross, but you can even view it to say at the end, if I am to continue the line, it can also meet with the other lines. Lines which are parallel, they are parallel. We cannot say these lines are parallel. No, that is impossible. If it is like this, then we can say, okay, these lines are parallel. Then we have to measure, are they equal or unequal, all of the three? If all the three lines are equal, it is a translation. But of the three lines that we have, the moment we just see, if there is just one which is bigger than in terms of length compared to the other ones like this, it's no longer a translation. It is now a reflection, an equal length. That is where it plays a role. So I talked about this. Just make sure that you do revise. Okay. So this one, we are not going to have parallel lines, but the lines, when being joined, these corresponding points, there is a condition where they are going to intersect. So there is an intersection which is going to happen. There is an intersection. We are not going to have anything parallel. So once you see this on an isometry, it's only a rotation. There is no translation like that. It can never be a rotation. It can never be a reflection. It can never be a translation on isometries. Take note, on isometries. We are on isometries where the object and the image are congruent, exactly the same, of the same size. All right. So now that you have seen that there is a point of intersection, you have concluded to say, okay, of all these three transformations that I'm having, it's only a rotation that can have a point of intersection when points are being joined, A to A1, B to B1, C to C1. It's only a rotation. So now we need to describe that. Just like what we had on the other two. We had to describe a translation, to describe a reflection. So it is the same. A rotation you are supposed to describe. So to describe, all right? So to describe a rotation fully, to describe a rotation fully, you are supposed to fully describe it. What is it that you need to describe this rotation? So when you are describing, I said you do not explain to the examiner that these lines that I'm joined, they are parallel, then they're equal. No, the examiner does not need to know about that. No, they don't need to know about that. They need to know the transformation. You have seen that. You are describing to say, okay, this is, you are the one who have seen that. If this is occurring, then what is it that is happening? Which transformation is it that is that is occurred? Like the transformation that you have used there to transform one shape to another. A shape has been transformed from where it was to another point. Now you have to describe. So this is it, what you're going to have. So you have to state the type of transformation first. That's the first thing. You state the type of transformation. So you're going to state it is a rotation. It is a rotation. So you state the type of the transformation that you're given. So on a rotation, you are going to see that there is going to be what we call the center of rotation. So you also state the center. That's the only transformation, if you can see from all the transformations that we had on these isometries, that had a center. There was no center here. There was a translation vector. So reflection, what was special about a reflection? There was a mirror line. A rotation, there is a center of rotation and also the angle. All right, so you state the center of rotation. So you need to know what's special about each transformation. On a rotation, there's a center of rotation. Then, so the center of rotation is just the coordinates, just like XY. So you're gonna write this as coordinates, e.g. XY, like 5, 2. Maybe it's about the origin, which is 0, 0. You just write the coordinates of that, okay? So you state the center of rotation. Then you also state the angle. All right, so there's an angle of rotation. So you state the angle of rotation, the angle of rotation and its direction, and its direction. When I'm talking about the direction, an angle can be taken. Remember, direction can be clockwise or anti-clockwise. If going this way, the way the clock moves, this is what? Clockwise, okay? The same way the clock moves like this, okay? In this movement, that's how the clock moves. So if we oppose how the clock moves like this is now an anti-clockwise. Anti-clockwise. So that's your direction. So the direction can be clockwise or anti-clockwise. So you can even write this with a sign. An anti-clockwise, it is, a clockwise, this one that we are seeing in the first place, it is represented with a negative sign. Whenever you see a negative on an angle, that's a clockwise. Guys, be careful on that one. Be very, very careful. Remember trigonometry. I talked about trigonometry. If we still remember in our trigonometry, I explained about angles to say an angle can be taken from this as 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360 degrees. Let's consider how these angles were taken. The moment that you are moving from 0, the angles are increasing this way. Look this way. 0, 91, the angles are taken, they're increasing this way. Which direction is it? It is an anti-clockwise. An anti-clockwise. That's where the angles are written. 0, 90, 180, they are positive. So in an anti-clockwise, you're going to see it's positive. But the moment you take them in the normal clock way, which is the clockwise, these angles are taken as negative angles. I explained about that in trigonometry. Make sure that you do watch the video so that you understand more about this. All right, so that is what I'm simply saying. A clockwise, using this consideration, these are negative angles. So the moment I see a negative 90 degrees, what does it mean? It means 90 degrees clockwise. 90 degrees clockwise. The moment I am given a positive 90 degrees like this, it means what? 90 degrees anti-clockwise. Anti-clockwise. So that's the idea of the angle. So an angle, if you want to write it in terms of the direction, but in this direction in terms of a sign, a negative is for the clockwise, positive, anti-clockwise. I'm sure you are going to, you're going to remember this. Okay, let's just hope you are going to do as much revisions as you can just to make sure, just write. You see now, I'm going to explain about how you find the center, the angle using a question, because you might not even understand if I try to explain it here. But after the question now, I can try to rephrase that so that you understand. So this is it here. This is what I want you to do. Challenge yourself from now onwards. Okay, you have done these transformations now. Also, there are videos there for enlargement, shear, and stretch. So I'm not going to focus much on those. I'm going to focus on those using question papers because I talked about those. Make sure that you watch those videos also after these ones. So this is what you're going to do. You work each just try to write. You see what I'm doing like this? Just try to summarize like this before exam. Try to summarize. Just try to summarize each to understand that now I understand the translation. Summarize everything like this. Then also to describe, just write in short, like short notes. But you are just asking yourself, then you check, okay, each transformation, okay, am I correct? That's how you can train yourself to understand these transformations, all right? Just write down translation, parallel lines of equal length. If I join the corresponding points, then to describe what is it that I'm supposed to describe a reflection, to describe a rotation, you're done. The rest, we're going to talk about it, how to find this center and so forth. So in this major class, it's on the rotation. So we are going to focus on this rotation. So this is it. We're just going to try to have an example to see how to describe how to have that center and so forth. So this time I'm just going to, okay, let me just maintain a scale of 2 centimeters to represent 1 unit on both axes. So this is, okay, let me check if this is the actual graph, because I've got, okay, sorry for that. I've got 2 questions that I need to explain. 1, 2, 3, 4, 5, 6, 7. All right. So we are just going to use this one, 2 centimeters to represent 1 unit on both axes. All right. So you'll be given also under exam condition, they will give you a certain interval for the values of x. Where are you going to write your x values from up to? All right. So so that you just do not just write like any way. Okay. You'll be given the scale, and also you'll be given the interval where your values of x are taken from up to. So this is our Cartesian plane. Just like our previous case, remember, guys, we had to draw the triangle, the image, and the object. So this time, I'm not going to take that time to talk about that. I'm just going to draw 2 triangles that we are going to work with. Triangle ABC. Now, guys, you understand me. Please just allow me to shorten this so that we explain more within a short video. Okay, so this is it. Let's say we've got triangle ABC with coordinates A, 1, 2. At this point, let's say there's a point A, the point B being 1, 4. Let's say there's a point B being 1, 4, and the point C, which is 2, 4. All right, the point C, which is 2, 4. I hope by now you understand this part of our coordinates, how to mark the points. Okay, so make sure that you just do revise on that part of marking the points, then also joining the points that you are given, forming a triangle. We talked about that. All right, so let's say this is our triangle ABC, which is our object. And we are given the image of this triangle with its coordinates. Maybe this is A1 with a 2 minus 1, which is point A1. So we've got A1, 2 minus 1, point B1, which is 4, minus 1, which is B1, and C1, which is 4, minus 2. We also have point C1, which is 4, minus 2. Then you join just like the previous case, all right? So this is going to be like this. You formulate your triangle, A1, B1, C1. Let's say this is what you had, okay? This is what you have. A, B, C, and A1, B1, C1. Then the question is asking you to describe now. Describe the single transformation. That's the question. Describe the single transformation which maps, or which we will map, okay? Which maps triangle ABC, which is our object, triangle ABC, onto triangle A1, B1, C1. Okay, this is what exactly the question will be like. A single transformation means say there's just one. It can be a reflection. It can be a translation. It can be a rotation. what specifies now, what is going to separate each are the properties that we mentioned before here. These properties that I had. One, we can see truly these are isometries. The object and the image are exactly, guys, this is exactly the same. From A to B, 2 boxes. From A1 to B1, 2 boxes of the same scale. A right angle triangle to B, a right angle triangle there. From B to C, from B1 to C, exactly the same length. This is your congruence. They are congruent figures, isometries. So there, I'm going to expect one of these 3 transformations. Either it's going to be a translation, a reflection, a rotation. So to have a final say to say this is A, we must have these consideration where we must join our corresponding points. We then conclude from there. For now, we do not have a conclusion. No, do not even conclude. We do not have a conclusion there. So by joining these points now, we can conclude to say, okay, this is a rotation, a translation, or a reflection. A to A1, you join using broken lines. Do the same thing. This is your B to B1 using broken lines. And also you join C to C1 using broken lines. Okay, let's see and summarize and analyze what just happened. There's just something here. There's just something that just happened. What is it? What is it that just happened here? The crossing of lines. It's true. This is not crossing with this A to A1. They are not intersecting, but the fact that there's a part which crosses alone, that alone, the fact that this is happening, it cannot just happen on any other transformation. When the 2 figures are congruent like this, never, it is just going to be a rotation, only a rotation. That's why they are saying a single, there is only one transformation that is going to be like that. They are not going to be 2, never. So be careful. Whenever there is an intersection on isometries, take note. I'm specifying this because there's another transformation that is going to have like that. So make sure that you revise your enlargement there because there's going to be a crossing there, but that one, it will be a smaller triangle to a bigger triangle or a bigger triangle to a smaller triangle. That one is on its own. But when the figures are isometries, they are congruent, it's only a rotation. So once you see this happening, now you can describe. To describe a rotation fully, you have to specify it is what? A rotation. You have seen that it is not a translation, it is not a reflection, but it is what? A rotation. You now specify the transformation. It is a rotation. It is a rotation. So like I said, you are going to need the center to state the center, which is the coordinates xy. So do not rush to say, so the center is this one. No, it's not like that. There is a way that you're supposed to do to determine this center. All right. So to determine the center, I'm just going to determine it while it's explaining also on the other hand here. So to determine the center of rotation, okay, or to find, okay, let's just say to find the center of rotation, okay, to find the center of rotation. So this is what you're going to do. You bisect any 2 corresponding lines that you have joined. You joined B to B1, C to C1, they intersected. So you bisect these 2, any 2. In actual sense, you were supposed to bisect all the three lines. You bisect A to A1, you bisect B to, just like what we had on when you wanted to find the equation of the mirror line. You had A and A1, then you had to bisect A to A1. Remember how to bisect the line. But there, you only had to bisect one line, one. By bisecting one line, that is your equation of mirror line. But this time, for a rotation, you were supposed to bisect all the three lines, A to A1, B to B1, C to C1. You were supposed to bisect all the three. But because now, if you bisect all these three, let's say these are the bisectors, you bisected A to A1, you bisect B to B1, maybe it's like this, you bisect C to C1, maybe it's like this. You were going to see that the bisectors, all the three bisectors, this is the point of intersection, the point of intersection of all the three bisectors, of the three bisectors. All the three bisectors, they are intersecting there. Where they are intersecting, that is the center of rotation. Not this point of intersection, this one. This one is for us to know that it's a rotation. Not to say that's our center. It's not like that. You have to bisect. But now this is it. I want you to understand this. This is the point of intersection of all the three bisectors. Okay, what is going to happen if I remove one bisector? Let's say I remove this one, okay? Let's just say I remove this bisector, this one. Is it going to affect my center? If I remove this, like this one, there was a line here like this. If I remove this line, is it going to affect where this center is? Because this line was passing through the center like this. So if I remove it, is it going to affect? No. It's not like this line was like this. No. The line is also passing through where these two bisectors meet. So it means if it does not affect my center of rotation, it is enough to bisect only two lines. There is no need for you to bisect all these three. No, just bisect two. When you bisect, or once you bisect two lines at the point of intersection, that's our center. So in this case, let us just conclude like this. Bisecting. So in this case, bisect any two corresponding lines, any two lines, bisect any two lines. That's e.g. A to A1, B to B1, okay? So you bisect any two from this one that you joined, A to A1, B to B1, okay? So after bisecting these two lines, the point of intersection is the what? Is your center. So the point of intersection, the point of intersection, the point of intersection represents the center. So it represents the center of rotation. Okay, so it's not much, guys. It's not much. Please just try to be with me. So this is what you're going to do. You bisect any two, but from my explanation that I think now you understand that the reason why we have to bisect two, not to bisect all of these three. Okay, so we are to find the center. We are to find what? The center. So to find the center, we have to bisect. So just follow these steps a little bit. I'm going to summarize everything at the end. Maybe you understand that way. Okay, so this is it. Let us bisect. So in this case, I'm going to choose B2, B1, C, and C1, okay? Not to say because they are the ones that are intersecting, so I'm going to, no, any. I can even bisect A and A1. But in this case, I'm going to choose B and B1. Remember how you bisect a line, you open more than half of the line. That's B to B1. So I'm just going to open more than half of this line. After opening half of the line, what you're going to need in this case is going to mark an arc just where you expect your bisect. As you can see, we just expect our bisector to be somewhere there. So where you expect your bisector to be, just construct an arc. In this case, I think we are two. Let's just try to be around this way. All right. So let's just construct from here. Do not make big arcs because remember, this is not the only part that you're going to have. There are other constructions to be made. All right. On the other side, you do the same thing. Just going to make an arc here. Just going to construct an arc. All right. I think this is enough. All right. Without changing this distance, do not change this, guys. I hope you are following from your construction. All right. You do not change this size. You mark the point B1. Remember, I'm using B to B1. So I'm going to use the this part of B1. On this side, mark an arc. On this other side, I'm supposed to mark an arc. All right. So as we can see, these two arcs, they do meet at a certain point. So with this, I can join from these points where these two are intersecting. All right. You have to join now the point of intersection where these two are intersecting. So using the ruler, I want you to join using the ruler these points that we are seeing. All right, that is going to be, I just hope it's going to pass through these points. All right, I'm just going to adjust it. Okay, something like this. So you're going to have something like this. Make sure that it passes exactly through these points. All right, something like this. Let your line also be big enough. So what is important, it passes through the point of intersection of these arcs that you marked from B to B1. But remember, you are supposed to bisect how many lines? 2. Bisect any 2. Okay. So you bisected B to B1. So you can also bisect C to C1. All right. So in this case, I'm going to use C and C1. All right. So at point C, you open more than half of the line. So I think here we are at more than half of the line. That's at C1. So we are supposed to mark C and C1. We just mark where we expect our arc to be. All right. Just somewhere there. You mark an arc. All right, let's try and have it also on this other side. Let's hope they are going to meet. Okay, something like this. Okay, let's move on to C1. This is without, you do not change this length. You can just change the position, like how to rotate, but do not change the length that you used in the first place. So you mark an arc. All right, so these two are not going to meet. They were supposed to meet somewhere here. So do not worry about that. What do? You just have to refer back to B1. So without changing this length, I mean to point C, you refer back to point C because these two are not intersecting. So we refer back to point C like this. We mark again. So they must intersect now, okay? We do the same this side. As you can see, this side, they are going to intersect somewhere there. All right, so meaning to say, this piece that I'm having here is not important. All right, no problem. Let's just leave it like that. So these are the ones that are intersecting here. They intersected this point. They intersected this point. So you join just like the previous case, all right? You must join these lines, and also you can use continuous lines to join. There's no problem. So we need these two bisectors, this one and this one. So just gonna join like this. All right, so use your ruler to join these, okay? So once joining the, as you are joining these bisectors, the bisector of B to B1, the bisector of C to C1, you bisected the lines. These two lines, the bisectors, they are intersecting at the origin. And also take note of your points, guys. Somehow you can, because these are constructions, somehow you might make a slight mistake on your bisection. Then it's just slight around, maybe at 0,1 or 0,2. You cannot take that to be your center. It's at the origin. So also learn to correct yourself under exam condition when it is like that. All right. So as you can see, all these bisectors, arcs that you are seeing, do not erase them. That is part of your working. Just make sure that they are not as big as what we are having here. All right, yes, because I can't be accurate, but as you can see, as you are constructing, guys, you can even erase other part to say, okay, let me just remove this part. Let me just remove this part. Okay, but this is it. At the intersection, which is the point of intersection, let's refer here, the point of intersection represents the center of rotation. So when you bisected this one, so what I'm trying to say, even if you're to bisect A to A1, you were going to see that the bisector of A to A1 was going to pass through the same point, which is your center. So that is our center. Which point is it? It's at 0. So that is the center about the origin. So the center of rotation, remember, we need the center. So it is a rotation. Then the center of rotation, you state the coordinates now. So this is the origin. At the origin, the coordinates is what? It's 0, 0. So if it was at this point, that 4, 0, you just have to write the coordinates there of the point, which is the center of rotation. So that's how you find the center. You bisect what? Any corresponding pair. Any corresponding part, B to B1, C to C1, any two. Then you need the last part on your rotation. It is to state the angle of rotation and its direction. So we are supposed now to state, okay, when this triangle is being rotated, because you rotated triangle ABC from where it was to this position, it was being rotated. So we need to know which angle are we going to use from ABC to this image where it is. But as you can see, this movement here that we are seeing from this point moving this way, which direction is it? That's a clockwise. But you can also mention it on the other way using this way, which is what? An anti-clockwise. So I'm going to explain that an angle can be, guys, make sure that you watch the video on trigonometry, where I talked about that, even the part of equal angles. When you're talking about a quadrant, angles can be taken to say an angle, maybe I want to refer this angle of minus 90 degrees. It is equal to the angle that is taken from the other way in the anti-clockwise direction. These two angles are equal as long as they're taken from the same point, ending at the same point. I talked about that. So make sure that you do watch the trigonometry part. It can be of importance. Okay, so we need the angle there. So to determine the angle, this is what you're going to do. You join any of these now. So now we need, this was to find the center. Let's talk about the angle now. So this time we need to find the angle. So to find the angle. All right, so to find the angle, this is what you're going to need. You are going to join, okay? You join, just follow up, guys, you understand. You are going to join these corresponding points to the center. So you join corresponding points to the center, e.g., A to the center and A1 to the center. All right. So this is what I'm trying to say. So you join any corresponding points to the center of rotation. So remember, we have the center of rotation. So you're going to join any any. When I'm saying any, you just use one. Whether you want to use A to the center and A1 to the center, or you are using B to the center and B, any one. You do not take all of these, just one. You just take any of your choice. All right. So you join any corresponding, e.g., A to e.g. A and its image. Okay, e.g. A and A1, its image. All right, to the center. Okay, to the center. So you join, if this is A and this is A1, and maybe the center is here. So you join from A to the center, A1 to the center of what? The center of rotation. Then you can measure the angle that is between these two. That is how you can take it. So you can also do the same B and B1. You can also B and B1, which is the image to the center. You can use C and C1. It's your choice. Just any. So as you can see, guys, if I have this A to the center, A1 to this, I can measure this angle. So you have to measure the angle at the end. So that's what I'm trying to say. So in this case, let me just use the points which are a little bit far from the center. Remember, our center is this one. That's our center, the origin. That's where we have the center. So you're going to join either A to A1, A to the center, A1 to the center, or B to the center, B. It's a choice. All right. So in this case, I'm going to take B and B1. But like I said, guys, you use any of your choice. All right. So I'm going to take B1. All right. And also on join, you can just use broken lines there. Let's just try to use broken lines. All right, let's just try to use broken lines. So I'm going to join B to the center. All right, B to the center like this. Then also B1 to the center like this. This is what I'm trying to say. You join these points to the center. B to the center, B1 to the center. Don't even worry to say the examiner is going to see. They are going to see this. Everything, they will see this. So you now measure the angle that is between B and its image. Between B and its image, you want to know this angle. What is the angle that is connecting B to its image passing through the center, this angle? So even by sight, you can see this is a 90-degree angle. This is a right angle that we are seeing here. Or you can measure, okay? But the first thing is that the direction, which direction is it? Which direction is this? That's a clockwise direction. So you can even see that's a right angle by sight. Or you can measure using our protractor. So this is it. We just gonna remember, how do you measure your angles from your construction? This plus here, this plus here must be on the center. So you place it on the center. So one line has to cover this line, which is black, has to cover this red line from B. It must cover with this one. You see where the 1/8 is, it must lie on that. So if you measure properly, from B here, we are going to measure from this 0, 10, 20, 30, 40. So the angle that corresponds there to B1, if you take note here to B1 here at B1, the one that is going to B1, if you consider B1 here, to the protractor, this one, B1, which angle is it corresponding? It is corresponding to what? To 90 degrees. From B, it is corresponding to 90 degrees. So this line must be from B, this one must be from B to the center. So you now take it now from B1. So B1 corresponds with what? With 90 degrees. So it means this angle is 90 degrees from where it is. Which way are we going? Which direction is it? As we are moving from the object to the movement is from the object. Remember, you transformed A, B, C onto A1, B1, C1. So which direction is this? That's a clockwise direction. So the angle of rotation is going to be 90 degrees clockwise. Okay? So the moment that you write 90 degrees clockwise, okay? So these are points, guys. Do not take this like minus. These are points, all right? The moment you write the angle of rotation as 90 degrees clockwise, someone can write the same angle of 90 degrees clockwise using the sign. Remember, I said a clockwise, these are negative. So you can also conclude just like minus 90 degrees, just like that. But let's refer back to our trigonometry there. I said that an angle that is taken from the same point in the same way can be equal to another angle in the other direction this way, which is the anti-clockwise. So if this angle is 90 degrees clockwise, it means also this triangle ABC was transformed the other way in the anti-clockwise direction, which is from 360 degrees. 360 minus 90 is what? 270. So you can also write this as 270 degrees anti-clockwise. Anti-clockwise. So it simply means a rotation of 90 degrees clockwise is the same as a rotation of 270 degrees anti-clockwise. So under exam condition, they can also give you this just to make sure that just for confusion's sake, you know, these guys, they will give you something like that. And maybe you need to even use your matrices, or you need to describe that, but they you are given as a 270 degrees anti-clockwise. You know that, okay, this is a 90 degrees clockwise, the same as a 90 degrees anti-clockwise. A 90 degrees anti-clockwise is same as what? A 270 degrees clockwise. It's just like that. So that's how you describe a rotation fully. To describe a rotation fully, you need to state it is a rotation. You need to state the center. So to determine the center, we said we bisect what? Any two of the corresponding points, B to B1, C to C1, or A to A1. You bisect. Where these bisectors meet, at the point of intersection of the bisectors, any two, where they meet, that is the center of rotation. Then you need the angle. To find the angle, you join object to the center, the image also to the center. You measure the angle that is in between. Any part that you want. You can choose C and C1 connected to the center. Then you measure that angle. You can even choose A to the center, A1, but even by side, you can see this is a right angled triangle that is there. You can see that. That's the whole part of your rotation. All right. Then we are going to see that, okay, so this one, I just need you to do revise. Here, I just need you to work with more questions. All right, let me use this space here. I think it can help us to explain another part, which is also important. That is actually a special type of a rotation that you can have. Of the angles of rotation, remember, this is a transformation. You are rotating a shape. So you can, these are the most important angles in your syllabus. 90 degrees, it can be 90 degrees anti-clockwise or clockwise. All right. Once I talk about 90 degrees, I'm also talking about what? 270 degrees. Remember, I said a 90 degrees clockwise is opposed with a 270 anti-clockwise. A 90 degrees anti-clockwise is opposed with a 270 in the other way, just like that. So the moment that you refer to a 90 degrees, you're also referring to a 270 degrees. Then also there is an angle of 180, which is the special angle that we have under a rotation. These ones are not special because 90 and 270 is the same. Whatever that you are doing there, that is what you're going to do, even if you want to write it as a 270, it's just 90 degrees there. 360 degrees, guys. If you transform something, a shape, let's say a point, you transform it 360 degrees. Where is it going to be found? If a point is being transformed 360 degrees, it is going to be at its original point where it was. So there is no transformation like a 360 degrees. We are not going to have something like that. It means you are just, the object is where it is. So they will never ask you to describe a transformation which maps a shape where it was. It cannot be like that. So we want to see this special type of a rotation of a 180 degrees. What is special about this? Okay. If it was to be taken from triangles, remember a triangle, it is a shape with three sides. Considering the object A, B, C, and its image, if it was to be taken from a triangle, you were going to see that if you were to join the point A to its image, maybe it is A1, you are joining these points. You also join B to its image, which is B1. You join, maybe there's a C here to its image, which is C1. You were going to see that this time, all points, all these that we are joining are going to intersect at a single point. Guys, this is it. Let's go back here. So that's why we had this question so that we can refer for. This is what I'm trying to say. When you joined before, A to A1, B to B1, C to C1, only these two intersected. Only these two, they intersected here at this point. Check, A is not going to intersect at this point. No. I'm talking when you are joining points, when you are joining A to A1, B to B1, C to C1, when you are joining those points. On a 180 degrees, when you are joining, they are going, all of these three, they are going to pass through the same point. That's the special part of a 180. Other transformations, it can be like this. There are only two. The other one is like this. They are not, even if they are to join, they are not going to join all of these. They are going to, no. It's only a rotation of 180 degrees that has got this special part. So once you see this happening, that I joined A to A1, B to B1, do not worry about anything to measure, to bisect, no. Once this happens, that point of intersection of these lines that we're joining A to A1, B to B1, C to C1, that point, it becomes the center of rotation. That point, it becomes the center of rotation. So meaning to say, if this is XY, that is going to be our center. So meaning to say, to describe, you are going to mention it is a rotation. The center now becomes that point. And remember, the angle is of what? 180 degrees. That's the special part of a rotation of 180 degrees. So I want to explain this with this example so that you can properly understand what I'm trying to say here. Let's say you're given the same scale of 2 centimeters to represent 1 unit on both axes, and you're given something like this. You just want to see how they can give us these questions. All right. Just to make sure we are together on this one. So that's 5, 6, 7, 8, and so on and so on. So this is our y-axis, 8, 9, 10, 11, and so on. Okay, so this is it. I'm just going to take this part. So this is it here. So let's say we are given 2 triangles, just like the previous case, guys. I'm just going to use that one that we had. A, maybe it's 1, 2. That's our A. B, maybe we've got a triangle B, 1, 4. Let's just say B, it's 1, 4. And C is 2, 4. And let's say there's a point C, which is 2, 4. All right. Just like the previous case, you join the corresponding points to form our triangle. It was going to be like this. All right. Sorry for that. B to C, just join, just like the previous case, forming your triangle. All right. And also, let's say there's an image of this triangle given as A1, maybe something like 5 versus 8. Let's say I've got a point 5 versus 8. All right, I'm just going to reduce so that we see this. 5 here versus 8. Let's say there's a point there, 5 versus 8, which is A1. And B1, 5 versus 6. Which is our B1, and C1, which is 4 versus 6, which is C1. Okay, and you also join these to form a triangle, just like this. All right. So this is what you're going to have at the end, like this, okay? Remember what we had before. Now, let us consider the question that we are being asked to describe, just like the previous question, the single transformation which maps A, B, C, which is our object. Let's say that's the question. Describe the single transformation which maps triangle ABC onto triangle A1, B1, C1. Seeing that these two are isometries, they are congruent to each other, the object and image, we are going to expect for all those three transformations, then we do the right thing to join the points just as previously mentioned. You were going to join A to A1. Okay, let me just choose another one here. You were going to join A to A1, just like previously mentioned. B to B1, C to C1. This is what you're going to do, joining all the points, just like previous. But by doing this, we can see that once these points are being joined, they are intersect, all this, everything is intersecting, guys. When we were joining these points, it was not about finding the center. No, it was about finding like which transformation is it? Is it a translation? Is it a rotation? Is it a reflection? Totally, a translation is out, a reflection is out because we do not have parallel lines. We are just left with a rotation now. Under that rotation, there's a special type of a rotation that we have where these intersect all of these three, which is when the angle is of 180 degrees. That is what is happening. It's only when this is of 180 degrees. So once you see this happening on isometries, guys, it means the single transformation which mapped the triangle ABC onto triangle A1, B1, C1. It is a rotation. It is a rotation. Then the center of rotation. So our center is, that's where these three are intersecting. That becomes the center. That's the special part of it. We are not going to bisect like what we had, where I said you have to bisect A to A1. If you do that, I want you to do that. Bisect A to A1, B to B1. You are going to see that your bisectors are going also to pass through that center also. So do not waste your time. It's a special type of a rotation, this one. So the center is where these two meet. 3 versus 5. That is this point. So x is 3. So that's our center of rotation, 3, 5. And the angle being of what? The angle of rotation being 180 degrees. That's the angle of rotation, 180 degrees. That's the special part of our 180 degrees. You don't need even to measure to say, guys, put a protractor, the A to A1, that's a straight line. That's 180 degrees, a straight line. So it's a special type of a transformation that you need to understand. So this marks the end part of our isometries in terms of the describing. Remember, like what we had under a translation, a reflection, there were questions that you were going to, where you were going to draw the image given the type of a transformation and the condition, like we are given also the translation vector for a translation, given a mirror line for a reflection, and you're being asked to draw the images. It is the same thing even for a rotation. They are going to ask us questions to draw the images given the object, given that it's a rotation, and also the center and the angle. They want you to draw the image. So it is going to be best that we explain that part, or just we have that part in terms of matrix method, the part of our matrices. So we are going to talk about that. we're going to have a class where we are going to talk about matrices, using matrices under transformation. So transformation, we can also use matrices. So the matrices that we are going to talk about, they are going to affect only two under isometries. There are two transformations, not to say that's the only part. No, these matrices, they are also there in shear. I explained those matrices under shear, under enlargement. So make sure that you watch those videos. I explained that part. There's a video there on shear, enlargement, everything. So I'm going to explain the ones for a rotation and a reflection. This is the one that you are going to have at the end. A translation, we do not have matrices under a translation. It is the only one under transformation without a matrix. There is a translation vector. Remember, a translation vector is in the form of a matrix. So that's our matrix. There is a translation vector. So the matrices, we are going to have the effect of these matrices on reflection and rotation. So I'm going to explain about that. But make sure that you watch those videos on what? Enlargement. Okay? Your shear and stretch. I explained those matrices there because the next part after this is matrices for rotation and reflection. After that, question papers, we are done. So make sure that you do your favor to watch those videos under the other part, the shear. We are going to just have those under question, using question papers only. Okay, we have the videos already.